This video is about the principle of mathematical induction, sums of powers of formulas, and finite differences of sequences. The principle of mathematical induction. Let P sub n be the statement involving the positive integer n. If P1 is true, and for every positive integer k, the truth of pk implies the truth of pk plus 1, then the statement P sub n must be true for all positive integers n. Example 1. Find P sub k plus 1 for the given statement pk. So the pk is k square over 3 times k plus 1 square. So just substitute where k is k plus 1. So P sub k becomes P sub k plus 1 and k becomes k plus 1 square. 3 stays and k changes to k plus 1, and then we already have plus 1 in the square. So we simplify, so k plus 1 square is k plus 1 square, 3 stay the same, and 1 plus 1 becomes 2, so it becomes k plus 2 square. So pk plus 1 becomes k plus 1 square over 3 times k plus 1 squares. Example 2. We have pk is 2 over k plus 1 times k plus 2, and we have to find p sub k plus 1. So let's start with p sub k equals to 2 over k plus 1 times k plus 2. So let's substitute k equals to k plus 1. So pk becomes p sub k plus 1. 2 stays, change k to k plus 1, and copy the 1, and then change k this k plus 1 and bring the 2 down here. Now simplify the bottom, so you have a 2 over k plus 1 plus 1, 2, and it's become k plus 3. So when pk is 2 over k plus 1 times k plus 2, p sub k plus 1 becomes 2 over k plus 2 times k plus 3. Example 3. Use the mathematical induction to prove the formula for all integers n greater than or equal to 1. 6 plus 12 plus 18 plus 24 plus 6n equal to 3n times n plus 1. So number 1, show that S1 is true. So let's start with S sub n, sum of n terms. So which is 6 plus 12 plus 18 plus 24 plus 6n equal to 3n times n plus 1. So substitute n equals to 1. So it becomes S1 equals sum of one term, which is first term 6. On the right side, put where the n is 1. So it becomes 3 times 1 times 1 plus 1. 1 plus 1 is 2. So 3 times 1 times 2 would be 6. So 6 equals to 6, so true. So we can say S1 is true. So number 2, we assume that S sub k, sum of first k terms, 6 plus 12 plus 18 plus 24 up to 6k. Where 6k come from? We had a 6n, so we just replace with the k's n equals to 3k times k plus 1. So this basically in the right side we replaced where the n is k. So we can assume that 6 plus 12 plus 18 plus 20 plus 6a is 3k times k plus 1. And now we're going to show that S sub k plus 1, sum of first k plus 1 terms, is 6 plus 12 plus 18 plus 24 plus 6k plus 6 times k plus 1 is equal to 3 times k plus 1, k plus 1 plus 1, 3 times k plus 1, k plus 2. So we're going to show that this one. So we start with this one and try to get this one. So let's see, s sub k plus 1 is 6 plus 12 plus 18 plus 24 plus 6k plus 6k plus 1. Well, this is sk by assumption, and this is equal to 3k times k plus 1. So we wrote here. So now we add this one, let's distribute, become 3k squared plus 3k plus 6 times k, 6k, 6 times 1 is 6. Simplify gives you 3k squared plus 9 plus 6. So basically we're trying to get this formula. So we factor out 3 becomes k squared plus 3k plus 12. Now we factor the trinomials, we get 3 times k plus 1 times k plus 2. It looks like exactly the same as this one by direct substitution in the n is equal to k plus v in the formula. So since both are the same, so we can say by mathematical induction that the formula is valid for all positive integer values. Okay, sum of powers formulas. So sum of c, I from 1, c is constant, so we simply c times the upper limit cn. Number 2, summation of I. Summation I mean 1 plus 2 plus 3 plus n is equal to n times n plus 1 over 2. Summation of I squared would be n times n plus 1 to n plus 1 over 6. Summation of I cube would be n squared times n plus 1 squared over 4. So these are formulas we can use. So example 4, we're going to find summation I from 1 to 15 of I. So let's start with the formula for summation of I from 1 to n of I is n times n plus 1 over 2. So because of this, upper limit is 15, so we substitute n 15 where the n is. So this becomes summation I from 1 to 15 of I equals to 15 times 15 plus 1 over 2. 15, 1 plus 1 is 16, so it becomes 15 times 16 over 2, so that would be 120. Example 5, let's find summation of I squared, I from 1 to 6. So let's write the formula for the summation of I squared, I from 1 to n. This is n times n plus 1 times 2n plus 1 over 6. Upper limit is 6, so n is 6, so we're going to substitute where the n is. So this becomes summation I from 1 to 6 of I squared is 6 times 6 plus 1 times 2 times 6 plus 1. Well, 6 plus 1 is 7. This belongs 2 times 6, 12 plus 1, 13. And divide by 6. So 6 cancels this one. 13 times 7 is 91. Example 6. We're going to find the summation of I4, I from 1 to 5. So we write the formula. Summation of I4, I from 1 to n is n times n plus 1 times 2n plus 1 times 3n squared plus 3n minus 1 over 30. So upper limit is 5, so we're going to substitute n is 5 where the n is. So this becomes summation I from 1 to 5, I4, and it becomes 5 plus 1, 2 times 5 plus 1, 3 times 5 squared plus 3 times 5 minus 1 over 30. So we simplify, so it becomes 5 times 6 times 11, and plus 75 plus 15 minus 1. So it simplifies to 29,370 divided by 30, so it will be 979. Example 7. So we're going to find this sum using the formula for sum of the powers of integers. Summation of I from 1 to 6, 6i minus 8i cubed. So let's write down this formula. I from 1 to n, 6i minus 8i cubed. Let's break it down into two summations and factor out. So we have a 6 times summation I from 1 to n of I minus 8 times summation I from 1 to n I cubed. Now we use this formula. Summation of I is n times n plus 1 over 2. Summation of I cube is n squared times n plus 1 squared over 4. So we wrote these formulas here, and since upper limit is 6, so we substitute 6 where the n is. So this becomes 6 times 6 plus 1 over 2, 8 times 6 square plus 6 plus 1 square over 2. So we simplify this one. So you got 126. If you simplify this one, it should be 3,528. Subtract gives you 3 minus 3,402. Finite difference. The first difference of sequence can be found by subtracting the consecutive terms. So let's say we have a terms are 3, 5, 8, 12, 17, 23. So 5 minus 3 is 2, 8 minus 5 is 3, 12 minus 8 is 4, 17 minus 12 is 5, and 23 minus 17 is 6. So this is the we find these are the first differences. Second difference would be, let's say, second difference are found by subtracting the consecutive terms. So let's see, AN is 3, 5, 8, 12, 17, 23. So first difference is 5 minus 3 is 2, 8 minus 5 is 3, 12 minus 8 is 4, 17 minus 12 is 5, 23 minus 17 is 6. The second differences are 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1, 6 minus 5 is 1. Finite difference and type of model. The sequence is a linear model when the first differences are all the same. The sequence is quadratic model when the second differences are all the same. Here is an example 8. So decide, this is a sequence given to us 5, 14, 23, 32, 41, 50. And we're going to decide whether this sequence can be represented perfectly by a linear model or a quadratic model. And then we have to find the model. So let's start with it. Write down all the terms 5, 14, 23, 32, 41, 50. And then find the consecutive difference. So 14 minus 5 is 9, 23 minus 14 is 9, 32 minus 20 is 9, 41 minus 32 is 9, 50 minus 41 is 9. So the first differences are all the same. So we'll say the sequence is a linear model of the type A sub n equal to an plus b. So now we have to find A and B. So now we're going to fit the linear model for this sequence. So earlier we determined that the linear model is A sub n is equal to A times n plus b. So we substitute n equals to 1. So it becomes A1 equals to A times 1 plus b. Now A1 is 5, so we're going to set A times 1 plus b is 5, which is A plus b is 5. So we have equation number 2. Let's see, add it again. Okay, the first equation is A plus b equals to 5. We solve this equation. Move the b to the right, so we have A equals to 5 minus b. Now the second equation is 2a plus b equals to 14. So we substitute A equals to 5 minus b in this equation. So this equation becomes 2 times 5 minus b plus b equals 14. Now we distribute 2, so it becomes 2 times 5 is 10 minus 2b plus b. Combine the b's, so it becomes 10 minus b equals 14. And now we can move, since b is negative and variable, we can move this to the right side. So and 14 to the left side. So it becomes 10 minus 14 equals to positive b. 10 minus 14 is negative 4, so we have a negative 4 equals to b, or we can say b equals to what? Negative 4. So now we found the b, now we have to find a. We can use this equation. A is equal to 5 minus b. So we substitute b equals to negative 4, so this becomes a equals to 5 minus minus 4. So negative 4 is positive 4, 5 plus 4 is 9. So now we go to the linear model. The linear model was A sub n equals to A times n plus b. So we substitute A equals to 9 and b equals to negative 4. So the linear model becomes A sub n equals to 9 n minus 4.